Good afternoon, everybody. Let us start our today's discussion. Today we will discuss about the medicinal chemistry week 12 assignments, its questions and its possible answers. Okay. So is my screen visible
Yes, sir.
and I am audible too?
Yes, sir.
Okay, okay. Okay, so let's start with the first question. Okay, in first question, it is asking that which of the following physiochemical properties is least commonly considered in user studies? Is this hydrophobicity or electronic influence of substituents? Is this dipole moment or size of substituents? So at first, we need to know what is QSAR. Okay, so what is QSAR? What is the full form of QSAR?
Quantitative structural activity relationship.
Quantitative structure and activity relationship. Okay, so what does it mean then? Quantitative structure activity relationship QSAR is applied for the decrease in the development of relationship between physiochemical properties of chemical substances and their biological activity. Okay, so this is basically a model. This is a in silico computational study. Right. In this study, we generate a model, training model, and another is the test model. Okay. So we develop a very reliable statistical model for prediction of the activities of the new chemical entities. The fundamental principle underlying the formalism is the difference in the structural properties is responsible for the variation in the biological activities of the compound. So basically, we try to relate a correlation between its chemical structure, and its activity on the biological model. So, in the classical QSAR studies, affinities of the ligands to their binding sites, inhibition constants, rate constants, and other biological endpoints with aromatic group or the molecular properties such as lipophilicity, polarizability, electronic and the steric properties, or with certain structural features have been correlated. However, such an approach has only a limited utility for designing a new molecule due to the lack of the consideration of the 3D structure of the molecule. So, 3D QSAR is a very recent technique, very advanced technique, is emerged as a natural extension of the classical Hansch and Free Wilson approaches, which exploits the free dimensional property of the ligands to predict their biological activities using robust metric techniques, and it is served as the valuable predictive tool in the design of the pharmaceuticals and the agrochemicals. Okay, so 3D QSAR model are discussed in this way. So what we do basically, so in silico computational study, there is a large number of the molecules like A, B, C, D, E, F, and various. There are many molecules whose various kind of properties like solubility, EC50, IC50. These values are already there in this model. Okay, so there are various entities for various kind of compound. So in this way, with the known compounds, we generate a training set, right? So with these various kind of physiochemical properties, we can detect its binding with some macromolecular protein or the receptor, depending on its solubility in the its lipophilic or in soluble in some polar solvent or EC50, IC50 fluid. Depending on the this kind of value, its binding energy with some receptor or the macromolecule can be predicted for the known molecules. So from this, we can generate a new set of molecule like X, Y, Z. Suppose this is the new set of the molecule, and with the correlation with this type of molecule, we can predict whether these molecules will bind in this pocket, in this pocket of the receptor or the protein. So this is training set, and this we call the new molecule or the test set. So why we do this kind of analysis? Because it minimizes the cost and the time and the chemical expenditure. So depending on this computational study, we can validate or we can predict which kind of molecule is going to show the best results in our biological study, in the drug development study. So in this way, it minimizes our time, our effort. Okay, so in this way, in the computational model, we can predict in QSAR study the activeness activity of our compounds. So the what is least commonly considered in QSAR model? Our answer of this question is
Dipole moment.
dipole moment. Okay, so let's see why dipole moment is the least commonly considered QSAR studies. The most commonly investigated properties are the hydrophobicity of the molecule, the electronic influence of the substituents, and the size of the substituents. The dipole moment is not often considered. In quantitative structure activity relationship QSAR studies, various physiochemical properties of the chemical compounds are considered as descriptors to develop model that can predict the biological activity of the compounds based on their structural features. So suppose in this test set there is some in A there is some OH, in B also there is some OH, but there is some OMe in the C. Okay, there is some OET in this case. So suppose in solubility A and B are the showing the better result. Okay, in the polar solvent as there are some OH groups is there. So in solubility these things I better A and B. So from this, if this unknown compound having also a OH group, then we can predict, then that system, the software can predict that whether this compound is better soluble or not. So in this way, with the structure and activity relationship, a correlation is drawn. Okay, so from there, prediction is done by the software. Okay, the choice of the properties to include in a user model depends on the specific study and the goals of the research. Okay, so the quantitative structure activity relationship is a method used in the chemistry and the biochemistry to develop mathematical models that can predict the biological activity of the chemical compounds based on their structural features. User studies aim to establish a correlation between the structural and the physiochemical properties of the compounds and their biological activities, which can help researchers design and develop new compounds with desired biological activities. In a user study, a data sheet, which I already shown that a previously recorded data sheet is there with lots of compounds and its physiochemical properties with known biological activities is used to develop a predictive model. The structural and the physiochemical properties of the compounds, such as molecular weight, hydrophobicity, electronic properties, and the conformational flexibility, are used as descriptors to represent the compounds in the model. The biological activity of the compound, such as binding affinity, enzyme inhibition, or the toxicity, is used as the response variable. Okay, so there are various kinds of variables are used like solubility, then biological activity such as binding affinity, enzyme inhibition, toxicity, which I said that the EC50 or IC50 value, or toxicity. Toxicity profile is also measured whether with the presence of certain groups, compounds is becoming toxic or not is used as the response variable. Various mathematical and the statistical methods such as the regression analysis, artificial neural networks, and support vector mechanics can be used to determine the R square. To develop user model, the quality and the accuracy of the models are assessed using statistical parameters such as the coefficient of the determination R2, cross validation, and the external validation. User models can be used to screen large chemical libraries and prioritize compounds with the desired biological activity for further experimental testing. User models can also provide insights into the structure-activity relationship of compounds, which can help researchers design and optimize compounds with improved activity and properties. Okay, so is this clear? The basic idea of the user, why we do the user study.
Yes, sir.
Okay, so any question or any doubt from this?
No, sir.
Okay, so let's move to our next question. Okay, in our next question, it is asking that which of the following resistance mechanism describe the function of the beta lactamase? Now, what is beta lactamase? What is its function?
Beta lactamase is an enzyme which can inactivate the beta lactam ring.
Which
It
can
degraded the beta lactam.
break or degrade the beta lactam ring. And beta lactam is very common in the penicillin type of moiety antibiotics. Okay, to resist this, the bacterial resistance generate this beta lactamase to break that beta lactam ring, right? And what is the answer? Which of the following resistance mechanism?
Yes, it will inactivate the drug. Drug
Yes,
inactivation.
drug inactivation, right? Okay, so let's see what is drug inactivation. The resistance mechanism that describes the function of the beta lactamase is drug inactivation. Beta lactamase are the enzymes produced by some bacteria that can hydrolyze and inactivate beta lactam antibiotics such as penicillin, cephalosporin, carbapenems. Right? These antibiotics have a beta lactam ring in their structure, which is essential for their antibacterial activity. Beta-lactamase break this ring by cleaving the amide bond, resulting in the loss of the antibiotic activity. As we know that it is a cyclic ring with nitrogen and double bond O. So what does it structure? A cyclic N and C double bond O. Why do we call it? is cyclic amide,
cyclic amide.
right? Here N and here C double bond O is there. Okay, so resulting in loss of the antibiotic activity. So drug inactivation is a common mechanism of bacterial resistance to the beta-lactam antibiotics, and beta-lactamases are one of the most important enzymes responsible for this resistance. Some bacteria can produce multiple types of the beta-lactamase, making them resistant to a wide range of the beta-lactam antibiotics. The production of the beta-lactamase can be chromosomally encoded or acquired through the horizontal gene transfer. So, due to the mutation, bacterial genes are very fast mutated. So, when they see such kind of antibiotics are there, the beta lactamase containing antibiotics, they rapidly mutate and produce some kind of enzymes which can break the beta lactam ring. Other resistance mechanism to the beta lactam antibiotic include target overproduction. Okay, so what is target overproduction? In which the bacteria produce more of the target enzyme, such as penicillin binding proteins that are inhibited by the antibiotics. Target mimicry involves the production of the proteins that mimics the structure of the target enzyme and bind to the antibiotics, preventing them from inhibiting the actual target enzyme. Efflux pumps are another resistance mechanism in which bacteria can pump out the antibiotics from the cell before they can reach to their target sites. So all other three are explained here, that what is efflux pump, that is excreting the antibiotics before they can reach to their target site, target mimicry, and the target overproduction. So all these three are not correct, and our desired mechanism in case of beta lactamase is the drug inactivation, right?
Yes, sir.
Okay, is this clear? Then we can move to the next one.
Yes.
Okay, okay. So it is saying that when two drugs act on the same receptor, the resulting drug interaction is said to be which of the following? Is this predictable or unpredictable or additive or synergistic? What we call it? Is this predictable or unpredictable or additive or synergistic?
Additive effect.
Additive effect. Okay, let's see why do we call it additive effect. So when two drugs act on the same receptor, this is very important. Same receptor, and produce an additive interaction, the resulting effect is equal to the sum of the effects of the each individual drug. In other words, the combined effect of the drug is no greater than that would be expected based on their individual effects. Additive drug interactions are predictable and can be calculated mathematically. For example, if drug A produces 50% reduction in the blood pressure and drug B produces 30% reduction sorry, in blood pressure, then the combined effect of the two drugs would be 80% reduction in the blood pressure. Okay, so this additive effect is predictable and can be used to guide the dosing and treatment decision. Do you get it? Why are you
Y-
calling it as the additive effect?
Yes, sir. Yes, sir.
Now, additive drug interactions can occur when two drugs have similar mechanism of action. Okay, voice is low. You cannot hear me. Now it is okay. You can hear me.
Yes, sir.
Okay. Okay. So additive drug interaction when the two drugs have the similar mechanism of action or produce similar physiological effect. For example, two drugs that both reduce pain by blocking the same type of receptor may produce an additive effect when used together. Overall, additive drug interactions are generally predictable and not associated with significant risk or adverse effect. However, it is important to be aware of the potential of the additive interaction when processing multiple medicines, as this can impact the effectiveness and safety of the treatment. So, what is our answer? That is additive effect. So, when the two mechanism of action and its receptor, its targets is nearly same of the two drugs, then the effect, combined effect of these two drugs is can be determined as the additive effect. Can you tell me a common example of two drugs taken together? Painkiller, two painkiller are used, that is aspirin and acetaminophen. These two drugs are taken together as the painkiller and can be seen as this combined effect of these two drugs. Okay, so this is where additive effect is explained. Right? Is this clear? Any doubt or any question?
No, sir.
Okay, then we can move to our next question. Okay, so now it is asking that what sort of value of sigma would signify an electron withdrawing substituent. Is this a negative value or positive value or zero, or it is impossible to say? Electron withdrawing group, what value is there? Is this positive, negative, zero? What?
Positive.
Positive effect. And what equation is this? The basic equation? This is Hammett equation. You have aware about the Hammett equation? So why what it is saying that Hammett equation is describes the linear free energy relationship and reaction rate. Okay. For many reaction, it is describing the flow of reaction electron towards the reaction. Okay, so it is basically a parameter which is describing the electron flow in the reaction through a equation. Okay, so what is the basic equation? Log sigma into rho. Okay, so k is the, as we know, that the constant. Okay, and reaction constant, substituent constant, sigma is a substituent constant, and rho is the reaction constant. Okay, so in this way, depending on the nature of the substituents, we say that whether sigma is positive or the negative in a positive reaction. So when sigma is the negative, it is electron donating group. Okay, so suppose there are various kind of group is there. If we can see, suppose in a benzene ring substituent constant, we are dimethyl amino group is there in the benzene ring, amino group is there, methoxy group is there, cyano group is there, and nitro group is there. Okay, so now can you predict that what is the just magnitude? I am just writing the data, you have to say what is the magnitude of would be there before the substituents. This is the para substituents. In all cases, this is the para substituent. Now, can you tell me what would be the sign for the dimethyl amino group? Depending on its electron donating or electron withdrawing capacity. So depending on that, the sigma, the substituent constant value, the sign of this value is changed, the magnitude of the sigma. Okay, so now tell me what would be is this, it will be positive or negative for dimethyl amino group? This is the dimethyl amino, 2 dimethyl, and here some benzene group is there, para position. Now tell me, can you predict that what would be the sign? Is will be positive or negative?
Positive.
Are you sure? Is this electron donating group or withdrawing group? Dimethyl, the lone pair is there in nitrogen. What we have
And
answered,
donating
that electron donating, then what will be its sign? Negative or positive?
it
You have answered this question. Na? A positive value of sigma would signify an electron withdrawing substituents. Then what will be this value of sigma for electron donating group?
Negative.
Negative. Is this clear for everybody?
okay,
Why
so
are we putting negative or positive sign?
Yes, sir. Yes.
You have answered this question, na, that a positive value of sigma would signify an electron withdrawing substituents. Then
Yes.
for electron donating group, it will be negative.
Negative.
Negative. And for amino also, the sign would be
Negative.
negative. For methoxy group,
it should be also
methox
negative.
methoxy is OMe. So oxygen has also lone pair. So it would be also
Negative.
negative. But for this one, cyano is this one,
Positive.
positive. Because cyano is an electron withdrawing group, right? Can you follow here that this amino and cyano has the same magnitude, 0.66, but the magnitude are different. Here it is a negative value and here it is a positive value, right? And for nitro group it will be
Positive.
positive. Very good. So is this clear? I think that for the electron donating group, as we have answered this, it is negative. For dimethylamino, whatever electron donating group is there, I have just noted here a few. That is methyl, ethoxy, hydroxy, butyl amino. Any kind of electron donating group will have the negative value, and any kind of electron withdrawing like fluoro, chloro, bromo, iodo, like trifluoromethyl, these have the positive value. This negative value signify that electron is flowing towards the reaction, and this positive value determine electron is flowing away from the reaction. Okay, so let's see that what will be the answer of our question number 4. What sort of sigma value would signify electron withdrawing substituents? That we have already answered, that a positive value of sigma would signify the electron withdrawing substituent, that is positive value. Now what is the possible explanation? In organic chemistry, the sigma constant is a measure of the electron donating or electron withdrawing ability of a substituent group in a molecule. Okay, which we have already discussed that it is a measure, and the basic equation which describes this is the Hammett equation, right? The electron flow in the reaction is determined the free energy relationship depending on the substituents is determined by the Hammett equation. A positive value of the sigma indicate that the substituents is electron withdrawing, meaning it attracts electron towards itself and away from the reset of the molecule. Conversely, a negative value of the sigma indicates that the substituent is electron donating, meaning that it donates electron to the rest of the molecule and away from itself. A zero value of sigma indicates that the substituent is neutral or does not have significant electron on the electron density. Is this clear? I have already discussed that depending on the value, when it is electron withdrawing, it is attracting electron towards the itself, and it is less electron donating, so it is have the positive sigma value. And electron withdrawing substituents tends to increase the polarity of a molecule and decrease its electron density, which can affect the chemical properties, reactivity and biological activity. Examples of the electron withdrawing substituents include NO2, carbonyl, halogen groups. It is not possible to say that what value of the sigma would be for electron withdrawing substituents, as the values of the different substituents are well known and have been experimentally determined. For example, the sigma value of a nitro group is especially around plus 8, plus 710 or plus 8, around this one, while the sigma value of a carbonyl group is typically plus 1. However, the exact value of the sigma can vary depending on the specific molecular context and the method used to measure it. Okay, so is this clear? The Hammett equation and the sigma value. The what is the sigma? It is substituents constant. And what is the rho? This one, rho,
Reaction constant.
reaction constant. Okay. So any doubt or any question from this question?
No, sir.
Okay. Then we can move to the next one. Okay, which of the following is an inhibitor of the inosine 5 monophosphate dehydrogenase? So which one? Is this dopamine or propanaldol or ciprofloxacin or mesoribin? What is the answer? Which of the following is the inhibitor? Okay, let's see that inosine 5 monophosphate dehydrogenase IMPDH is an essential enzyme in the de novo biosynthesis of the guanine nucleotide, which are necessary for the DNA and the RNA synthesis in the cell. IMPDH catalyzes the conversion of the inosine monophosphate to xanthosine monophosphate. Okay, which is a key step in the synthesis of the guanine nucleotide. Mesoribin is a synthetic nucleotide analogous that selectively inhibit IMPDH by binding to its active site and preventing the conversion of the IMP to XMP. This inhibition reduces the production of the guanine nucleotide, which can immunosuppressive effects and make it useful in the treatment of the autoimmune disorders and organ transplantation. Okay, so what is the this is an important enzyme that IMPDH that is essential for the biosynthesis of the guanine nucleotide that is involved in the conversion of the inosine monophosphate to the xanthosine monophosphate, which is a key step in the guanine nucleotide. Now, what does this do? Mesoribin is a synthetic nucleotide analogous selectively binds to the IMPDH by binding to its active site and preventing the conversion of the IMP to XMP. This inhibition reduces the production of the guanine nucleotide, which can immunosuppressive effects and make it useful in the treatment of the autoimmune disorders and the organ transplantation. Okay. Now, what about the other options? That what is dopamine? Dopamine is a neurotransmitter that function in the central nervous system and is not an inhibitor of the IMPDH. Propranolol is a beta blocker that is used to treat high blood pressure and other cardiovascular conditions and is not inhibitor of the IMPDH. Ciprofloxacin is an antibiotic that inhibits bacterial DNA guidase and topoisomerase 4 and is not inhibitor of the IMPDH. So is this clear why it is used? What it is function of the four different compounds?
Yes, sir.
Okay. Okay, in the next question, what it is asked that what term is used to describe the process by which the best fit line is fitted through a set of the data points on a graph. It is linear regression analysis by the least square method or linear fitting analysis by the least square method, linear fitting assessment by the least square method or linear regression assessment by the least square method. What is the right answer? Okay, let's see. The term used to describe the process by which the best fit line is fitted through a set of the data points on a graph is the linear regression analysis by the least square method. This one, right? First one. Okay, so linear regression, what is then linear regression analysis? The linear regression analysis is a statistical method used to model the relationship between the two variables by fitting a linear equation to the observed data. In the context of a graph, Linear regression involves finding the best fit line that represents the relationship between the x and the y variables. Suppose there are various kinds of, this is the, what axis is this? This one? This one? Which axis? The horizontal one? Okay, this is x axis and this is y-axis. So there are various points are there. Suppose this is a straight line equation. So this line can be drawn like this, can be drawn like this, can be drawn like this, or can be drawn like this. So various kinds of possibilities can be drawn for the passing through these straight points. So this is a statistical method which predicts or which determines the best fit results, that which is the best fit depending on the data set on the xy variables. The least squares method is a specific technique used to estimate the parameters of the linear regression equation by minimizing the sum of the square differences between the observed data points and the fitted lines. Okay, the term linear fitting analysis by the least square method is similar to linear regression analysis by the least square method and refers to the same statistical technique. The term linear fitting assessment by the least square method is not typically used to describe this process and may be less commonly encountered in statistical literature. Okay, so in summary, linear regression analysis by the least square method is the term used to describe the process by which the baseline is fitted through a set of the data points on a graph. The least squares method is specific technique used to estimate the parameters of the linear regression equation by minimizing the sum of the squared differences between the observed data points and the fitted line. Okay. So what is our desired answer? That the term used to describe the processes by which the best fit line is the linear regression analysis by the least square method. That is the option 1. Okay, let's move to the next question. Okay, so this is also related to the Hammett equation, which we have already discussed, that which of the following statements is true, that hydrophobic compounds have high value of P. Hydrophobic compounds have a high value of P. Acidic compounds have a high value of P, and basic compounds have a high value of P. So what is P here?
Partition coefficient.
Partition coefficient. And between the two layers, what are those? The organic and the aqueous layer, right?
Yes.
Okay, so what is the right statement?
Hydrophobic compound have high value of P.
Okay, let's see. In medicinal chemistry and drug discovery, P that is partition coefficient, is a measure of the lipophilicity or the hydrophobicity of a compound. What is lipophilicity?
Compounds which are get dissolved in lipid.
Hmm. Lipid or fat?
Yes.
Okay, so the tendency then, what solvents like toluene or the benzene, like non-polar solvents, its ability or its affinity to be get dissolved in the non-polar solvents, like, right? So it is a measure of the lipophilicity or the hydrophobicity of a compound. P is defined as the ratio of the concentration of the compound in two immiscible phases, typically octanol and water. The higher value of P, the more hydrophobic or the hydrophilic the compound is. Okay, so the hydrophilic compounds have a higher value of the P. So our right statement is hydrophobic compounds have a higher value of the P. The higher value of the P, the more hydrophobic or the lipophilic the compound is. Okay, so hydrophobic compounds tend to have a higher value of the P because they are more soluble in the nonpolar solvents such as octanol than in the polar solvents such as water. This is due to their hydrophobic effect, which causes nonpolar molecule to cluster together in order to minimize their contact with the water. So as we know that which is the hydrophobic molecule, suppose this is a hydrophobic molecule, this is a long chain fatty acid, this is a long chain and this is the long chain, this is some central moiety group R. So they will obviously tend to themselves in such a way that is they are far away from the water. As we know that the like dissolves like, so they are cluster or orient themselves in such a way that they are far away from the water. This is due to the hydrophobic effect, which causes nonpolar molecule to cluster together in order to minimize their contact with the water. In contrast, hydrophobic molecule tend to have a lower p-value. Hydrophilic compounds have a lower p-value because they are more soluble in the polar solvents such as water than in the non-polar solvents. Acidic and the basic compounds may have the higher or the lower values of the p depending on their specific chemical structures and the pH of the solvent system. For example, acidic compounds may have the higher value of the P at low pH when they are ionized and the more hydrophilic, while basic compounds may have the higher P values at the high pH when they are ionized and the more hydrophilic. Do you get it? The last part that it is saying that when in the acid, we know the acid condition COOH, that is lower pH, it says as the COO minus and the H plus, right? So in this condition, low pH, this is more water soluble. So at this that case, it have the higher value of the P at low pH as they are more ionized and the basic compounds ROH, they are minus in the high pH. So they are a high pH, they are more ionized, so they have the higher value of the P at the more pH. So it is that is why it is saying that depending on the pH, the P value of the acid on the basis depends. Okay, so hydrophobic compounds have a higher value of the P. Okay, so what is MR? What does MR represents in the user studies? What is MR? Molar refractivity is a steric factor, is an electronic factor, is an hydrophobic factor, or is a stereoelectronic factor. What is this?
It is steric factor.
Hmm. It is a steric factor. Molar refractivity, MR, is a steric factor. So molar refractivity is a measurement of the ability of a molecule to bend light as it passes through it. It is related to the polarizability of the molecule, which is in turn reflects the degree to which the molecule's electron cloud can be distorted by external electron fields. Molar refractivity is primarily a steric factor because it depends on the size, shape, flexibility of a molecule, which determine how it interacts with other molecules in its environment. So, what is molar refractivity? It is a measure of the ability of a molecule to bend light as it passes through it. Now, steric factors play an important role in determining the biological activity of a molecule as they influence how the molecule interacts with the biological targets such as enzyme, receptors, and the ion channels. For example, a bulky substituent on a molecule may prevent it from fitting properly in the active site of an enzyme, thereby reducing its ability to bind and inhibit the enzyme's activity. So how it related? Suppose two molecules are there. Suppose here methyl in one methyl group is there and another group tertiary butyl group is there. But in case of the receptor, in the active pocket of the receptor, suppose this is a small one. So suppose methyl group is fitting at that receptor. Depending on the shape and the size of the receptor, the small part, that is the methyl group, is fitting completely, but tertiary butyl group, due to its large volume, due to 3-methyl group, it is not fitting at the active point of the receptor. So in this way, steric factor plays a very important role in the medicinal chemistry drug discovery study. While molar refractivity is not an electronic or hydrophobic factor, it is only a steric factor, means in spatial arrangement of the molecule. It can interact with the other electronic and hydrophobic factors in Quasar equation to help predict the biological activity of a molecule. For example, the molar refractivity of a molecule may interact with the electronic effects of the substituents on the molecule to influence its activity, or with the hydrophobicity of the molecule to determine its solubility and permeability across the biological membranes. You got it? What is MR represents in the QSAR studies?
Yes, sir.
Okay. Okay, let's move to the next question. What does a negative value of sigma signify for a substituent? It's very easy. We have already discussed. What is it? Negative value of sigma signify it is electron. Positive value of sigma would signify it is electron withdrawing substituents. Then negative value of sigma would signify it is
Donating.
electron donating. Sorry, I have mentioned here donating. Okay. In organic chemistry, sigma is a measure of the electron withdrawing or electron donating effects of the substituents on an organic molecule. It is typically represents as the value of units of the electron withdrawing power with negative values indicating the electron withdrawing substituents and positive values for the indicating electron donating substituents. Sorry, here some mismatch is there, I think. It will be electron donating. And positive value would be for electron withdrawing, right? Okay, so now electron withdrawing substituents tend to pull electron density away from the rest of the molecule, making it more electron poor and less likely to undergo certain types of the chemical reaction. Example of the electron withdrawing substituents include halogen, nitro, and the carbonyl group. And in contrast, electron donating substituents tend to donate electron density to the rest of the molecule, making it more electron rich and more likely to undergo certain type of the chemical reaction. Example of the electron donating substituents include alkyl group, amino group, and the hydroxyl group. A neutral substituents would have the sigma value close to 0, indicating that it has the little or the no electron withdrawing or the electron donating effects on the rest of the molecule. Hydrophobicity is a separate property that is related to a molecule solubility in the nonpolar solvent and is not directly related to the sigma. Okay, so this we can answer from the Hammett equation that whether a group is having positive or negative sigma value depending on its electron donating or electron withdrawing ability. Okay, okay, let's move to our last question. So what it is saying, the Cuser equation relating the insecticidal activity of a serine of diethyl phenyl phosphatases versus sigma is shown below. Log 1 by C 2.282 sigma minus 0.348 R square 0.952 R is 0.976 and S is 0.286. So what is the answer? The regression or the correlation coefficient or the number of the compounds tested, the standard deviation or the F test. Okay, in the Cuser equation relating to the insecticidal activity of a series of the diethyl phenyl phosphatases versus sigma, the following terms are defined as the regression or the correlation coefficient R square. The term described how well the data fits in the line of the Cuser equation. This linear regression, what we discussed of the least square method, and R2 values of 0.952 indicates that 95.2% of the variation in the insecticidal activity can be explained by the variation in the sigma. The remaining 4.8% may be due to the other factors that are not included in the Cuser equation. The numbers of the compound tested, the term refers to the number of the diethyl phenyl phosphanates that were tested for their insecticidal activity in the study. The number of the compound tested is not explicitly given in the information provided. The standard deviation S, the term described how closely the data points cluster around the line of the Cuser equation. A smaller value of the S indicates that the data points are tightly clustered around the line, while a larger value of the S indicates that the data points are more widely dispersed. In this case, the standard deviation 0.286 indicating that the data points are relatively tightly clustered around the line of the Cuser equation. The F test is used to determine whether the Cuser equation is statistically significant or not. It compares the variance of the data points around the line of the Cuser equation, the residual variance, to the variance of the data points relative to the mean, the total variance. A high F value indicates that the residual variance is much smaller than the total variance, indicating that the Cuser equation is statistically significant. The F value is not explicitly given in the information provided. Overall, the Cuser equation for the insecticidal activity of the diethyl phenyl phosphonates versus sigma value appears to have a good fit to the data with a high R square value and relatively low standard deviation. However, additional statistical analysis would be required to determine the significance. So, our right option is the regression or the correlation coefficient. Okay, so is there any doubt?
No, sir.
Okay, so when is your exam?
On 30th May.
30, 30.
Okay, on 30th. 30th means it's Sunday, right?
Yes.
Okay, Sunday. So I think there will be a problem solving in the next week. Basically, if you have any kind of problem from any class or any concept wise. So I think it will be declared soon. So if you have any query regarding this or any uh, problem in understanding any concept, so we can discuss that in the next session. Okay, so good luck for your exam.
Thank
Uh,
you, sir.
Good
Thank
luck
you, sir.
and prepare properly for the exam.
Sir, how many questions are there for exam?
Okay, that I don't know actually. That depends on the examiner, so that is not declared. Uh, okay, so that nobody knows actually. That is completely the authority's decision. So,
Oh, okay.
okay, so good luck. Prepare properly, and we will discuss if anything there is there. We will discuss in the next class. Okay.
Okay, sir.
Okay,
Thank you.
sir. Thank
Okay.
you. Thank you,
Okay.
sir.
Thank you. Thank you for joining.
audible? Hello. So, am I audible?